Okay, so we now go to another topic that is on this emerging technology, right? So we go to this emerging technology, which we said in the last class, because of the time constraint we could not cover it, but today we shall cover it. And again, emerging technology, it is definitely those which are coming up or which might or might not have taken your commercial aspect or commercial application, but they have the possibility and they have the enough reasoning. Why should they be brought into this into commercialization, and that is also there. So let us look into that. So emerging technology, what are the drivers opportunity? Means why should we? Number one is the product quality and safety. So products quality and safety is well maintained or well adhered to. It may also can produce consumer convenience, as well if the total cost of the system is also comparable or it could be brought down. So then the emerging technology can come up. Otherwise, if you have a conventional technology, and if that is not so bad compared to the new technology, why people should come forward, unless it encompasses all these three factors, that is the quality and safety and your convenience of the consumers, as well the cross criteria. So if all these three are adhered to, then emerging technology can come up. Now if we look at then what are the technological advancements in that emerging technologies: packaging process, packaging material and value added features. All these are coming up also along with the technologies. That packaging industry has really gone up very high, and packaging materials also, many people are working on packaging, different packaging materials, and today or tomorrow some new and new materials are coming up, and that may help. This is called augmentation of the technology. If there be any emerging technology coming up, then this packaging industry, packaging material can definitely put up a big thumb into that. Okay. Now let us look into that. To do that, what could be the challenges which new technology or emerging technology may face with, right? Number one, that may be disruptive in the supply chain, because normally what the supply chain is ongoing when you are introducing a new technology, so that could hamper the supply chain mechanism. So that could be a challenge. So as early as it could be recovered, that will be good for both the producer as well as the consumer. Then infrastructure, that could be also a major challenging threat to the new technologies, because infrastructure, the more it is developed, better for the entire technology as well for the consumer. Asset flexibility over cost of capital. So asset flexibility or cost of capital means if you have whatever assets, because whenever you are making an industry, definitely you will have those instruments, equipments, those will be an asset, and also land area, buildings, etc., they become the asset. But how much cost you are to incur as capital, that also will have some challenge on the new technology to come up, because this asset come this cost, that should be also very lucrative. Otherwise, new people, new entrepreneur will think twice or may not come forward. And last of all, the safety regulations, right? So, if the safety regulations are well maintained, right, then definitely that will be helpful for the new technology to come up. So, what could be recommendations for the new technology to come up for the general people who are directly or indirectly associated? That is, the people should strategically cooperate, right? Strategically cooperate. They should develop skilled people. So, the new technology, the people who are doing for a long time with one type of technology, indigenous or conventional, or any technology which is ongoing, if that has to be replaced, so that skill of the people who are working, that should be also brought high. Otherwise, it is very difficult for the new technology to come up. Then consumer education, this is also required. In most of the cases, consumer means who is consuming, right? Anybody who is consuming can be said as a consumer. Now, that you just think of a nation like ours, where you as an educated engineer or technologist, what you understand and what some common man who does not have that much background or that much knowledge about the product, about the implications, about the plus and minus of the new technology. So, unless they are educated, it is not only the packaging by which you can you can impress on them, but it is also the education of the people that must be looked into, and you must be able to convince people with the new technology, right? Then let us look into that what are the emerging technologies. Since it will take, if we make the slide in the vertical, it will take a lot of space. So, to minimize that, I have made it like this. You see, consumer, what they desire, that is from the consumer point of view, minimally preserved and processed food, that is what they want. Then this should lead to more convenience in terms of shelf life, then in terms of storage, in terms of preparation for consumption. So, this convenience, both in terms of shelf life, storage, or in terms of preparation for consumption, that consumer wants, that it should be the most convenient. Then higher quality in terms of flavor, texture, appearance, that is also consumers' demand. It should be more fresher with the new technology, more natural and naturally healthier, right, or nutritionally healthier. It should be nutritionally also healthier as well, minimally packaged. Finally, it should be safer. That is the point which consumers want, that all these aspects, if taken care of, then introduction of new technology, perhaps they will have minimum resistance, they will be cooperative, right. So, retail, then you look into, not before going into the producer, let us look into that scientists and technologists, what they say. Scientists and technologists says that, okay, with minimal changes we can make milder processing with respect to minimal overheating, less intensive heating and fewer additives with respect to less use of chemical preservatives that can be brought into. So, as a technologist or as a scientist, they look into that, okay, we can minimally overheat or we can heat less, so that heat sensitive materials they are not damaged, and we can add few chemical preservatives, so that consumers which they wanted, that could be minimized, right. Then it comes to the level of, and along with that, increased use of combination of hurdle technologies, right. Combination of hurdle technologies, they say that yes, we can do this, that combination of hurdle, increased use of combination of hurdle technologies that can be done by the scientists, what they say. Then evaluation and use of naturally occurring preservation system that can be introduced, reduction in levels of salt, fat, sugar that can be done, reduced environmentally friendly packaging, right, reduced or packaging reduced or environmentally friendly packaging can be introduced, and more attention can be given to the elimination of food poisoning microorganisms from the most often contaminated foods. In many parts of the world, even in the developed countries where things are much developed, but even there this problem of getting contaminated or infection is rapid, or I do not say it is epidemic, but when it occurs, then it also may become epidemic depending on the product, and then the manufacturers withdraw those or withdraws those kind of products from the market, so that further damage can be controlled, right. So, scientists and technologists says that this can be taken care of with the new technologies, right. Then what are the existing technologies we have? To inhibit the growth of the microorganisms in food, we have lowering of temperature by chilling, freezing and storing at low temperature, by lowering the water activity, which we have by drying, curing, addition of sugar, all these we have by lowering of technologies. Then by lowering of pH, by acidification, right, which we have, that is either by acidification or by fermentation, we can lower the pH, by increasing the vacuum technology, that is by removing the oxygen from the packaged material. So, in by that vacuum technology or vacuum packaging is also there. We also have nowadays modified atmosphere packaging or MAP, where addition of maximum of carbon dioxide, oxygen or nitrogen, this adjustment can be done, not only addition, but also adjustment of the concentration of carbon dioxide, oxygen and nitrogen, that can be adjusted. Then addition of preservatives, that is also there, the inorganic like sulfite, nitrite, these are there, organic substances like sorbate, benzoate, propionate, these are also there, and some antibiotics like nisin, Nisin, that are also there, right. And there are also controlling food microstructure. By controlling food microstructure, like like that oil water emulsion, oil water or water oil immersion, right. So, depending on whether your oil is in the primary phase or main phase or continuous phase, or oil is in the continuous phase and water is in the dispersed phase, depending on that this is also there, right. To inactivate inorganisms in foods, what we do? We heat, right. We heat to inactivate, we heat, thereby we do pasteurize. For example, heating which we normally come across is by pasteurization, sterilization, or pasteurization, sterilization, drying. We have already drying is another, but this is with respect to liquid food normally. This is pasteurized and sterilized, right. And we also sorry. So, we also restricting access of the organisms we can, that is by packaging or aseptic processing or aseptic packaging also, packaging, aseptic processing and aseptic packaging, right. To use naturally occurring preservative systems, what is ongoing is bacteriolytic. Obviously, from the term bacteriolytic, it appears that the bacteria which can be kept aside, that is, it can be killed, or bacteriostatic which can be killed or which can be removed, and other enzymes, for example, isozyme or lysozyme, then lactoperoxidase. These enzymes do act on them. Some non-enzymatic proteins and other polypeptides, for example, nisin, then pediocin, then culture of products, then some lactoferrin, lactoferricin. All these are non-enzymatic preservatives which are used. Plant derivative or plant derived other antimicrobes which we use are herbs and spices, that is extracts that leads to the development of new method, right. Now, the efficacy of these methods, of course, that can be judged or assessed by the required commercial exploitation, how it can be proved that what is the efficacy, means how much it is fruitful to the product or with the system, that has to be exploited commercially, right. Now, emerging physical technologies which are coming up is by high pressure technology, right, or normally we call it to be HPP, high pressure technology. So, that high pressure technology or HPP, that can be miraculous, but again, as I said right in the beginning, that everything you have to keep in mind. It is not only the technology itself. This is a learning process, that is why you are bringing, but when you are considering to implement it, definitely we will keep all whichever we have already told in mind to decide on when the technology should be adopted or not, right. So, high pressure technology is one such which is coming up. I do not say which has come up, which is coming up, but where combination of ultrasonic, heat and pressure, all these are utilized, right, either HPP itself or in combination with ultrasonic method and heat and pressure. all these three could be used, and that is termed as Manothermosonication. That is termed as Manothermosonication, where combination of these three, ultrasonic, heat and pressure, all these three variables are used. Then high voltage gradient. High voltage gradient pulse, that is called electroporation. This technique is called electroporation, where high voltage gradient in terms of pulse. Pulse of course means, as you know, so this we call to be pulse, right. This kind of input we call it to be pulse. Then laser and non-coherent light pulses, right, where we could use that laser or light pulses for the inactivation or maybe as the new technology. Then high magnetic field pulses, again that can be used, where magnetic field can be used in the very high form, and that can also bring to our new technology. Okay. Now, if we look into distinctly different from that high pressure. Now, how much high pressure? It is high to the tune of that inactivates vegetative organisms by the pressure, right. In pasteurization, it is around 400 to 600 megapascal. You see megapascal, around 4000 to 6000 atmosphere. Atmospheric pressure is 1 atmosphere, right. And if you make it 5-6 atmosphere, then only it becomes a booming kind of thing. 4000 to 6000, right. This is of course not the pressure which gas pressure we think of. This is normally hydrostatic pressure, right. So, in that definitely such huge pressure can be built up. Now, why should we build? What it does? It does large species to species and strain to strain variation and very large protective effects from the constituents of some of the foods at low water activities. For example, Escherichia coli, that can be where this high pressure technology can be used. So, definitely how much pressure, how much you should apply, we have given a range of 4000 to 6000 atmosphere, right. So, at that high pressure, it varies from species to species or strain to strain, how much pressure should be applied, right. Example given, or we are putting that Escherichia coli, this number can be one such, right. Then Manothermosonication, where it is a combination of ultrasonic facility, heat and pressure, right. Now, what is the advantage of all these three? Ultrasonication at high enough intensities inactivate bacteria and reduces heat resistance of the bacterial spores. I hope we understand spores. Bacterial spores means if this is a bacteria, say rod shaped bacteria, when it is forming a spore, then it forms another coating around it, right? Around it another coating. So, this is very resistant to the cause given to it, right. It becomes very resistant. So, those which are in a high spore formers, they are more resistant and it is difficult to inactivate those. So, there this ultrasonication helps to inactivate these bacterial spores. The effect of synergistic effect. Synergistic means it is both together, right. Synergism, that is this A and this B both are acting together and jointly the effect is being available. So, that is why it is being called that synergistic, the effect is synergistic with raised temperature as well. The temperature, if it is raised, then overall of course, if the temperature is high, very high, then overall synergism is reduced. The reason being high temperature then comes into picture and the damage is done by the high temperature. So, that is why it is a combination of all these three together, right. Okay. Why the synergism is done, as we said, because as the vapor pressure of water rises, it has the effect of reducing the effectiveness of cavitation, which is the main cause of the microbial death, right. Vapor pressure, why it will raise? Because you are increasing the temperature. So, in temperature, vapor pressure is a function of temperature. So, the moment you are increasing the temperature, that will also rise the vapor pressure, and if vapor pressure is raised, then deactivation due to cavitation is reduced, and cavitation, formation of causing the cavitation is one of the primary reason why the organisms are destroyed. So, application of slight overpressure, if you maybe a few bars, or maintains the synergism at the higher temperature. Thus, combination. So, if you increase the temperature, then simultaneously you also increase the pressure, so that the vapor pressure difference that does not become significant, and that cavitation problem does not arise, right. So, it has the potential for reducing the pasteurization and sterilization temperature for pumpable liquids and for semi solid foods. Pumpable liquids, that means it has flowability. Now, if the viscosity becomes very high, if the material becomes very high viscous, then pumpability will reduce. So, it has to be, it can be applied to those where we have high pumpability of the liquid or of the fluid or of the food, right, or if it is semi solid, so that the pumpability is there, then this technique, that is application or in combination of synergistic effect of ultrasonic as well temperature and pressure, this in combination can be made effective. This is the technique which is coming up, right. I do not say it has come up, but like since we are discussing with the trends of the recently developed technologies, so this is one of them, right. So, the other two or others we will discuss in the next class, because our time here is perhaps limited. Okay. Thank you.